Hello guys, today I'm going to explain you what is center of mass, three basic questions on center of mass and every hack thing about center of mass. So center of mass denoted as COM, C for center, O for off and M for the mass. Now what is center of mass? Center of mass is a point where gravity acts at a very high extent than any other point on the object. Let us take an example of a whale. A whale, don't look at my diagram, it's not that good, but this is a whale and let us assume a center of mass here somewhere. So this is the point where all the mass of the object is being gravitized, or you could say the gravity acts on it at a very high extent. The gravity is very high at this point as compared to any other point on the object. Well, so this point is the center of mass. This is what is center of mass, and now I'm going to explain you about how to find center of mass of various objects. Let us go with a circular ring. Can you identify the center of mass for a circular ring? Well, of course you could predict it with the method known as symmetrical line methods. Symmetrical line method. What is a symmetrical line? A symmetrical line is a line which just divides the object into two parts of equal looking things. So this is equal as this, so the center of mass will lie, make another one, and the center of mass will lie at the center of the circle. Now if I go with a uniform rod, where is the center of mass? A uniform thin rod, it will lie at somewhere here. If the length of the rod is L, the center of mass would be L by 2. Now you have understand the concept what is center of mass actually is. What is center of mass? Now I would tell you three basic uh, formulas for finding out center of masses. So if center of mass is in x direction, as you know the axis is x, y, and the z1 in the third dimension. So what is xcm? Center of mass in x direction is m1x1 plus m2x2, and it goes on mnxn upon m1 plus m2 plus dot 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 mn. Same for ycm, just you have to change it as y1 and y2 and everything is same for ycm and same for the zcm. Now I'm going to tell you some examples to find out center of masses. I would go with one example which I have. Three particles of 1 kg mass are placed at vertex of a triangle angled at right angled at O. Just mark it, right angled at O. OA is equal to OB is equal to 1 meter. Position vector of comb is question mark. Now the first step you're gonna do is find the origin. So let us assume this as origin. Let us assume this as 0, 0. Now we are given this as 1 meter distance, so this is 1 meter and this is also 1 meter. So this is going to be in the y direction, as we take the axis as x in horizontal direction and y in the vertical direction. So this is going to be 1, 0, whereas this is going to be 0, 1. Now as I told you, the xcm is nothing but m1x1 plus m2x2 plus m3x3, as there are three masses placed here on the vertex, upon m1 plus m2 plus m3. Now we are given this as identical masses because they are of 1 kg, so just put it in there. That is 1 into the first the first axis is 0, and the other one's x axis is 0. X coordinate, I mean to say, x coordinate is 0 0 1. So it's going to be like, take the common one, as the mass is common, 0 plus 0 plus 1 upon the mass 3. It's going to be like this. Now we don't have any ZCM here, so it's neglected. And same for the YCM. We have YCM, you could get it as 1 0 plus 0 plus 1. As you could see, the axes are, you have 1 here, 0 and 0 for this. Now so you get it as 1 by 3, and here 1 by 3. So this is nothing but I cap, and this is nothing but J cap. So you are going to get it as 1 by 3 I cap plus 1 by 3 J cap, which is nothing but I cap plus J cap by 3. This is the position vector. This is the answer. Now the second one, I'm going to tell you the example in my next video. Thank you for watching this one, guys.